Good morning, everybody. Thank you for joining us today for the Ductless Heating and Cooling webinar. My name is Lorena, and I'll be hosting the webinar today. We would like to start with a safety moment. As you know, safety is a core value at PGE, and we want to remind you to be safe around electricity. As you consider installing or retrofitting new equipment at your locations, please keep safety in mind. We also encourage your family, tenants, and staff to be prepared with an outage kit. You can visit our website to find out more information around safety. For today's webinar, Portland General Electric has teamed up with the Metro Multifamily Housing Association, which their new name is now Multifamily Northwest, Energy Trust of Oregon, and the Regional Water Providers Consortium to offer multifamily property managers and owners 7 free seminars and webinars in the month of March that have proven strategies for saving energy and water, also information on cash incentives and available resources. Today's session is the second of its series. All of our seminars and webinars are free and also qualify for the Oregon Real Estate Continuing Education Credit Unit. So feel free to chat with me or let me know at the end of the session if you'd like to take advantage of those credits. Before I introduce the presenter, I wanted to show you some of the tools we'll be using today. Again, we want this to be informative but also interactive and engage you as participants. You'll notice on the right side of your screen is the participants window where your names are listed, and we have other people joining us as well. There's a raise your hand icon right underneath that if at any point you want to ask a question over the phone. We do have dedicated 10 to 15 minutes at the end where we will be addressing questions. So throughout the session, if you want to submit questions, right underneath the participants window is the chat window, and you can chat with me through there. That's also if you have any issues during the webinar. To the top left corner of your screen, you will also see this annotating tools. There's an arrow, there's a text, a T for the text, there's a highlighter, an eraser, and the presenter will let you know when to use those throughout the session. So Garrett is our product line manager at Portland General Electric, and he has over 10 years of experience in educating and advising customers on energy efficiency technologies, energy trust incentives, and what type of retrofits or upgrades they can do on their facilities. He has received a degree from Lane Community College in energy management and also a business management degree from Linfield College. So without further ado, I will go ahead and turn it over to Garrett.
Thanks, Lorena. Welcome all to the Ductless Heat Pump webinar this morning. First off, we're going to go over ductless heat pumps. I'll give you kind of an outline here. We're going to talk about typical multifamily usage, zonal electric heat, and ductless heat pumps. So first off, I'd like to know who you are. It's helpful to to learn the audience a little bit here. Using the toolbar up again at the left, I'll demonstrate. Say I'm a property owner. If you could tell me if you're a property owner, property manager, facility staff, or someone else, I'd appreciate it. I'll give you a moment to do that. All right, it looks like we've got a wide variety of folks joining the webinar today, so that's great. So the Northwest Energy Efficiency Alliance is an organization that's charged with market transformation, and that's introducing new technologies to the region, and they also do a lot of research into existing energy usage in different sectors. And fairly recently, the Northwest Energy Efficiency Alliance, or Ania, sponsored a survey of about 80 tenants in Idaho, Oregon, and Washington in the multifamily sector. So here are some of Nia's findings in apartments with electric resistance heat. So what they found is typically you're looking at about 10,757 kilowatt hours a year total energy consumption. So kilowatt hour is the building unit or the unit of energy that's consumed and the PGE charges for. And of that, nearly 11,000, nearly 4,000 kilowatt hours a year is for heating consumption in electric resistance heated apartments. And the resulting utility cost is over $1,100 a year. High bill could be $135 a month, and a low bill could be about $60 per month. So we'll cover the different types of zonal electric heat, typical wattage, how much it costs to operate these common zonal electric heating systems. So a baseboard heater, about 250 watts per linear foot. The hourly cost to operate a 1,500 watt 6-foot unit is about 15.66 cents. And a monthly cost, using an example of heating a 2-bedroom apartment for 4 hours a day would be about $75. So that's 2 4-foot and 2 8-foot baseboards. Wall heaters that usually have a fan and blower unit, those are also very common in apartments, range from 1,500 to 2,000 watts. They can range from 750 to 4,000. And so same cost, 15.66 cents for a 1,500 watt model. And in this example, it might cost $63 to operate 2,000 watt wall heaters into 1,500 watt wall heaters. And sometimes tenants use portable electric space heaters, and most are around 1,500 watts. Again, it's going to cost about 15.66 cents to operate for 1 hour. And for this kind of spot heating, you're looking at about $28 for one space heater. So that's one space heater that's probably just heating a small area and obviously not the whole apartment. So for zonal electric heating systems, Energy Star provides some guidelines. So occupied and unoccupied settings are a good strategy to reduce energy consumption in those homes that have these electric zonal heating systems. So the wake time, 6 a.m., 70 degrees or less is a suggestion. The daytime setting, when people are typically gone, set back at least 8 degrees. And then the evening in return, 70 degrees or less is a good recommended setting. And then a setback of 8 degrees around bedtime during the evening when folks are sleeping after 10. And then we have some cooling set point suggestions here as well that, for window units and so on. Sometimes are often seen in apartments. So some simple fixes for zonal electric heat. Make sure the mechanical thermostats are accurate, so check those for accuracy over time. They may not be providing the temperature that you may think that they are, so replacement may be necessary. Again, set temperature back based on occupancy. For example, 60 to 8 degrees when at home and awake, and 60 degrees when asleep or away. And set the temperature as low as possible. For zonal electric, use can drop 2% for every degree that you lower the average temperature. So significant savings with these systems by just behavioral changes that can be made. And operations and maintenance, zonal electric heating systems are pretty simple. Manufacturer recommendations are what you want to go with and trump all others. But typically you want to turn off the power and vacuum heater grills and fins regularly. Allow air to circulate. Don't block the fan discharge in the wall mounted units. And leave at least 1 foot between the baseboard and furniture or anything else just for fire hazard and so on. And also avoid drafts, so set the temperature zones to similar set points throughout the house. Or if you're zoning the area and only intending to heat certain areas, close off areas where the baseboards are turned off. So we'll do another quick survey here. Remember using the toolbar on the top left. I'm curious as for the property owners, managers, facilities folks out there, what kind of heating systems are most common in your units that you're involved with? All right, so I see a lot of baseboards and wall heaters, and those are probably two of the most common heating systems in apartments, so I'm not surprised. So now we'll move on and talk about ductless heating and cooling, or ductless heat pumps. So there really is a new option for multifamily units, and these are ductless heat pumps. And we just have a few photos here to kind of give you an idea what the ductless heat pumps look like. There's an outdoor unit here on the left hand side in that photograph, and then an indoor unit on the right there as well. So just kind of give you a sense if you haven't seen them before what they look like. We'll talk a little bit about how heat pumps work. So it takes less energy to move. Um, it takes less energy to move energy. Takes less energy to move energy from one place to another compared to converting it to electrical energy directly to heat. So in electric heating system, like a baseboard, basically all the energy that goes in the form of electric energy is converted to heat. With a heat pump, you're actually getting more out of it than you put into it because you're extracting heat from the outdoors. And so refrigerants are used to move heat from the inside to outside. So the indoor coil in the heating mode, the outdoor coil is, in the heating mode, the outdoor coil is significantly cooler than the ambient outdoor air. And heat always moves from warmer areas to cooler areas. So the outdoor coil is collecting heat from the outdoors. And the heat collected from the outdoors is transferred to the indoors through hot gas from the compressor in the outdoor unit. An indoor coil is hotter than the return air blowing over it. The return air becomes warmer, becomes warm supply air, and heats the house. So this is a typical, the diagram above is just a ducted heat pump system that's pretty common. So a little more on how heat pumps work. Heat pump has all the same components as an air conditioner, but also has a reversing valve that allows the heat pump to reverse the direction of refrigerant flow and providing the building with heat. So there are really five main heat pump components. There's the outdoor coil, which is a condenser, or the indoor coil, a condenser that rejects heat inside. The outdoor coil that acts as the evaporator in heating mode, and it collects heat from outside. The compressor, which is a vapor pump, and it's really the heart of the heating and cooling system. A metering device, which controls the refrigerant flow, and a reversing valve. So this is basically the device that changes the direction of the refrigerant and switches from heating to cooling. So why would you want to consider ductless for multifamily? Really, the ductless is going to be the best practical solution in existing apartment units. It's going to be the easiest and quickest to install. We're going to be looking at the highest efficiencies. So SEER is seasonal energy efficiency ratio, and that's kind of the seasonal efficiency rating of a heat pump and air conditioners. To kind of put things in perspective, the federal minimum code for SEER right now is 13, and we're seeing up to 22 SEER in ductless units. And HSPF is heating seasonal performance factor. That's a similar rating, but for the heating season. And so we're seeing 11. And federal minimum right now is 7.7. So again, significantly higher than standard basic code heat pumps. You're going to see the lowest cost with the ductless heat pump in terms of upgrading from zonal electric heat. They're extremely quiet for both the indoor and outdoor units. And it's proven technology. It's really only relatively new to the United States. So a little more specifically how ductless heat pumps work. A ductless heat pump moves heat from outdoors to indoors with efficiency of up to 3 times greater than zonal electric heat, so a big increase in energy efficiency there. It moves heat from indoors to outdoors to provide cooling, additional benefit. Typically, the systems utilize 1 outdoor unit, and you can configure these based on the model to have up to 4 indoor units. We'll talk a little bit more about some considerations when installing these in the options, but you can range from 1 to 4 indoor units from the same outdoor unit. Each indoor unit is individually controlled by remote control. And backup electric resistance is not required, and the system can operate effectively at low outdoor temperatures, typically better than a standard ducted heat pump. And I'll talk a little bit more about installation strategies and the need for backup heat and kind of the options here in a few slides. One of the reasons ductless heat pumps are very efficient is because they have variable capacity, or they use inverter technology. Most ducted systems will turn on and off as heating and cooling is needed. A ductless heat pump will basically operate based on the heating and cooling needs at any given time, so it operates maybe it's not an on-off operation. It just operates at a lower speed, and there's really high efficiency with this type of operation, variable speed technology. So a little history on ductless heat pumps. Ductless heat pumps were developed in Japan over 30 years ago, so they've been around a long time. For those of you who have traveled outside of the U.S., you've probably seen these. So they're commonly used in Asia and Europe for heating and cooling, and really all other parts of the world. They're just starting to take off here in the United States. We've seen a significant increase in the installation in the last few years. In the Northwest Energy Efficiency Alliance, that's the organization I referenced earlier, had a ductless heat pump initiative recently. I believe it was from around 2009 and wound down a year or so ago. But this resulted in 11,000 ductless heat pump installations installed in our region over the last several years. So there's a lot of these systems out there right now. So we've got a lot of feedback from our customers from who have installed these ductless heat pumps, and I'll just kind of go over some of the main points and common themes that we've heard. They're excited to have heating and cooling. It heats the home better than baseboard heaters, especially with the better air distribution. A lot of these indoor units will have the ability to basically throw the air up to 20 feet. Obviously, lower utility bills, one of the main benefits. They're amazed at how quiet the heat pumps are, and that goes for both the indoor and outdoor units. And this is really important in multifamily, too, with the outdoor units. You don't want to have really noisy outdoor units that are going to disturb neighbors. It's really not an issue. Hot supply temperature. Air is warmer than typical heat pumps with ducts. Typically, there's heat lost as the air travels through a ducted system, so you're getting hotter supply air temperatures with ductless units. I've actually taken some temperatures, some flyer temperatures, even at lower degrees in the 30s and 40s, and I've seen temperatures even in the 40s up to 120 degrees coming out of ductless heat pumps. So it's really comfortable, really hot supply air. And they really like the ability to control different rooms with an efficient heat source. When this is the case when multiple indoor units are used, typically in larger homes or sometimes apartments, but typically larger homes. So a little bit more on installation strategies. So as I mentioned earlier, you have one outdoor unit and you can install multiple indoor units, single or multiple indoor units. Probably for apartments, the single indoor unit is going to be the best option. It's going to be significant. You're going to see significantly lower installation costs with a single indoor unit. So what you'd want to do is locate the single indoor unit in the main living area. So maybe it's kind of a living room, kitchen area, and then you have bedrooms off to the side down to a hallway. You're going to have less impact on the exterior of the building. The refrigerant and controls lines, electrical are run up the side of the building. And it really works great in single-family homes and apartments. I've actually done some monitoring of temperatures in some apartments where in the bedrooms the units were actually disabled, and I didn't find that there was a significant decrease. I think it was less than 5 degrees typically in the bedrooms, and often people like a little lower temperature when they sleep anyway. And so there are still, typically, if you install the single family or the single unit in an apartment, the baseboards and wall heaters are left in bedrooms. They won't be used frequently, is what we've found, but you might want to leave them in place for extreme cold temperatures or for occupant comfort when needed. But we really don't see much use when they're left in place, even with a single unit indoors. So you can go the route for multiple indoor units. There's potential for more energy savings. Whether that's cost effective, probably not in a multifamily setting. And there is the benefit of being able to zone without electric resistance heat. But I'd say typically for smaller apartments and smaller homes, the single indoor unit would be the route to go. So what will the systems look like? The outdoor unit, it's usually mounted on the ground or on a patio on a pad. Or sometimes you'll see elevated installations on the exterior walls with a mounting bracket that's specifically designed for ductless heat pumps. And so there's refrigerant lines that connect the indoor and outdoor units. And the refrigerant lines, power, and communications require a 3-inch hole in the exterior wall to connect the indoor and outdoor unit. And in terms of aesthetics, you're probably going to want to use a rigid cover to conceal the refrigerant and power and communication wiring. Basically, it looks like a gutter downspout and typically is painted to match the building. So it really looks, it doesn't make a major impact in terms of aesthetics if you go that route and use the cover. As far as the indoor units, they typically mount close to ceiling height, within a few inches. They're approximately 3 feet wide and 1 foot tall. So here's an apartment installation here. It looks like the outdoor unit is on a kind of paver patio kind of deal, but with a foam pad underneath it. And one of the things I wanted to point out is that there is the, try to use my arrow here, that's the cover for the refrigerant lines. You can see the refrigerant lines coming out to the left of the unit and going up the side of the building. And then it has this cover and it's painted to the side of the building. I wanted to actually point it out because it's kind of difficult to tell that it's there. In the picture to the right, we have just an indoor unit. And in this photo here, we have a high-rise installation. So this is actually in downtown Portland. This was I believe, a 2,400 or so square foot apartment unit. The owner of this building actually decided to go with two units, two indoor units, because of the size of the building, and it wrapped around the corner of the high-rise building too. So it was kind of spread out and kind of cut up, kind of floor plan. But we have the outdoor unit that you can see through the sliding glass door there, and then there was a bedroom office where you can see the indoor unit. And behind the outdoor unit is where there's another living room, and there was another indoor unit located in that area as well. So in terms of operation and maintenance, ductless heat pumps are pretty low maintenance. Typically, they have washable filters that should be cleaned several times a year. Expected life is up to 20 years. So in terms of operation, operate in heat or cool mode. There is a auto mode, but for efficiency, we recommend either keeping it in heat or cool, depending on what season you're in. Avoid significant changes in settings. With electric resistance heat, you can rapidly bring temperatures back up. With a heat pump, it takes a little bit longer to increase the temperature. So if you have really deep setbacks, it'll take a little bit longer to recover. Small setbacks are fine though. And keep the temperature settings in bedrooms 5 to 15 degrees cooler than areas where the ductless heat pump is located. You want the ductless heat pump to be the primary heat source there. So again, back to kind of the physics, heat moves from warm areas to cool areas. So you want that ductless heat pump. You want the heat to be moving into the bedrooms and not the other way from the baseboard heat. I'll talk about an example of a local project. This was a 80-unit apartment complex. It was a 20-year-old apartment complex with 20-year-old baseboard heaters, and the owner decided to utilize ductless heat pumps in these units. The owner reported that several tenants said they had saved anywhere from $50 to $60 per month during the heating season. So savings is often hard to predict. There's a lot of factors. It depends on occupancy, age of the building, insulation levels, and so on. But there were some pretty significant savings that were reported to the owner there with this project. The tenants were extremely satisfied. They really liked their systems, and the owner raised rent to recoup the cost. And this is actually a photo of this particular project. You can see the remote control there and kind of a close-up of the indoor unit. And then taking a step back, looking at the indoor unit in the main kind of living room area. People really don't really object to the look of the ductless heat pump. It is a little different, the indoor unit, but after a while, people really don't even notice it's there. It blends in really well with the wall and so on. So, and this is again the same project with just a picture with the outdoor unit. I'm not sure why this particular owner decided to go with a mounting bracket, but they did, and I just wanted to show an example of what an elevated installation looks like with that mounting bracket. So in terms of the landlord perspective, what are your goals? Perhaps it's increase tenant comfort and happiness, increase tenant retention, decrease or eliminate vacancy, and greater cash flow, more rent per month. Then on the other hand, we have the tenant's perspective, and we'll look at your tenant's possible economics when considering a ductless heat pump. So tenant costs for a single level unit, possible winter savings with a new system, $50 per month. Of course, this is winter. And then what is added value for air conditioning? Maybe it's $25, $50, or $75 a month. And back to the landlord perspective, your possible economics in terms of payback. So let's say a ductless heat pump costs $2,900 after incentives. I'll talk a little bit more about incentives later in the webinar. The monthly rent increase could be $75, and this would result in a 3.2-year payback. So pretty good. And then we can look at internal rate of return and your return on investment. So you spend $2,900, you get $75 a month. With a term of 60 months, it results in a 16.7 internal rate of return. So again, pretty good here. So this is some information from HUD on why tenants move. There are a number of reasons. It could be to start a family, job relocation, costs, or other. So the other is safety and security, atmosphere, heating and cooling, noise, unhealthy environment, whether it's real or perceived, amenities or lack of, so schools, parks, transportation, retailers, Starbucks, and so on. So what can you affect? Well, you can improve the comfort factor. With a ductless heat pump, it's a better way to heat and cool, higher efficiency compared to window air conditioners, lower cost to operate compared to zonal electric heat. And we'll talk a little bit more about window air conditioners, because if you don't provide cooling, the tenants often will. So what are the problems with the portable air conditioner? They have a variety of names. Could be a window shaker or room AC. They're called window shakers because they're loud. They're blights on architecture, and they're ugly. I mean, they're really not aesthetically pleasing from the exterior perspective. There's potential structural damage due to water intrusion. So you'll see a lot of these window air conditioners left in year-round, and maybe not a great installation by a tenant could allow for water or rain intrusion, or condensate during the cooling season, dripping off the unit and potentially into the building structure. And security too. So tenant security, easier for break-ins if the window air conditioners aren't securely installed. And potential liability too. I see this unit here is held up. It looks like by VHS cassettes and maybe some tape there. So do you want an installation like this three floors up over a walkway? There's potential to harm folks if it's a poor installation. So we'll kind of compare the options here. Traditional ducted system, heat pump disadvantages. With a ducted system, it's a more technical install. The installer needs to make sure that airflow is right, duct sizing is right, and so on. So if done incorrectly, reduced equipment life. It could be oversized, poor airflow, and so on. And if done incorrectly for a lot of the same reasons, you'll see reduced energy savings. So what the unit is maybe rated at is not what you're getting. If replacing a zonal system, adding ductwork can be expensive, in a lot of cases, impossible. And it's considerably more expensive than the ductless options. So ductless heat pump system advantages. Ease of installation. They go in really quickly, kind of pretty non-invasive in terms of your occupant involvement. The installer can get in and out of there pretty quick and install these ductless heat pumps. Zoned, if that's the route you go, additional energy savings compared to a ducted system. Extremely high energy efficiency, so typically more efficient than a ducted system. No ductwork and ductwork energy losses. Typically, you'll see 20% loss in efficiency just through the ducts. So you're eliminating that with a ductless system. Again, extremely quiet and a compact outdoor unit. So in terms of size, I mean, we saw some photographs, but they're basically the size of a large suitcase, a lot smaller than a typical ducted system outdoor unit. So there may be some disadvantages. I don't think there are many with ductless heat pumps. But premium product may have premium price. So do your homework and make sure you're working with a contractor that's charging a reasonable price for the ductless heat pumps. Some contractors are unfamiliar with the technology and maybe reluctant to want to install that. With the big uptake in recent years, I'd say that is less of an issue than it has been in the past. I think contractors are really starting to embrace the technology. And I'd recommend requiring deposits for remote controls in case they're lost or broken and so on, so that the tenant is responsible for any damage or replacement of the remote controls. You can install hardwired hardwired controls for these systems. I wouldn't necessarily recommend going that route. I'd recommend just the deposit route. So right now, PGE, through its contractor, PGE-approved contractor network, is offering a special offer to multifamily owners. And the offer is a ductless heat pump system, a single head ductless heat pump system for $3,598 from PGE-approved contractor on a qualifying Frederick ductless heat pump system. There is a $600 energy trust incentive that's available, and a $200 PGE-approved contractor discount. And the 20th system is free. And I believe that this offer covers everything except a permit for a typical installation. Permits are going to vary by location and jurisdiction. And I'll leave the screen up here just for a moment, but here is the offer for the web link for this particular offer if it's something that you're interested in looking at. If you want to get in contact with a PGE-approved contractor, have them get in touch with you and get a quote for one of these systems in your rental units. So I mentioned the Energy Trust in the last slide. So the Energy Trust is the organization that offers PGE customers energy efficiency incentives to improve their commercial, multifamily, and residential buildings. So the Energy Trust is a nonprofit organization that's funded by a public purpose charge that all PGE customers pay on their utility bills. And we help connect our customers to these programs. And although we are covering ductless heat pumps today and the incentives involved with ductless heat pumps, there are other incentives available to multifamily property owners that you may be interested in. And these include attic floor and exterior wall insulation, clothes washers, either in individual apartments or for laundry rooms, common area lighting, that a lot of apartment complexes have, upgrading the old T12 lighting, for example, that's been phased out. Customized solutions for HVAC and water heating. So maybe you have an apartment complex that utilizes a central heating or cooling system. There are incentives to make improvements there. Exterior doors, gas boilers, tune-ups, boiler pipe installation, again, for larger multifamily properties. the incentives apply to gas systems as well. Of course, heat pumps, standard and ductless. Refrigerator replacement. So these are appliances that are regularly replaced. If you go with Energy Star units, you can get an incentive from the Energy Trust. Water heaters, again, a frequently replaced item. If you go with a high efficiency water heater, Energy Trust provides incentives there as well. Window upgrades are pretty popular too, and the Energy Trust provides window incentives. And the Energy Trust provides free on-site building assessments for multifamily properties. And you can receive a free energy efficiency consultation. So these are free to businesses. As far as multifamily, we can talk to you over the phone. The Energy Trust handles the on-site evaluations. If you have questions about the programs, you can visit us at portlandgeneral.com/business or contact Paula Conway, who is one of our outreach specialists. If you have questions on this particular ductless heat pump offer, or you have questions about kind of getting connected with some of the incentives that the Energy Trust provides, here's Paula's phone number and email address. And again, if you're interested in the special offer for the current Frederick ductless heat pump, there's the web URL for that offer again. And if you want to pick one of these just to get you in the frame of mind and get some direction, go ahead and click one of those boxes there. And with that, it looks like we're wrapping things up, so I'll turn it back over to Lorena.
Thank you, Garrett. And before we go into the question and answer portion, I want to remind you again that there is one more webinar on March 20th that you can join us at 8 or noon regarding saving with appliances. So this was one of those technologies, the mini split heat pump, that you can consider. But there are lots and lots of other ones for washer and dryer, shower heads, and whatnot. So we're going to cover those type of equipment and appliances on March 20th. We'll have the Water Providers Consortium and also Energy Trust present for those. You'll notice also on the right side of your screen there's a polling that will come up. Please take a couple minutes to fill those out and give us some feedback or other topics you'd like to hear more about so we can offer to you. All right, so the first question that came up, Garrett, is you mentioned that this technology is over 30 years old. How come it's taken so long to get over to Oregon?
Probably, I guess that's a great question. We have seen ductless installed in server rooms and stuff like that in commercial settings. In general, I think the United States sometimes is a little later to adopt and embrace technologies. But we really would give credit to the Northwest Energy Efficiency Alliance and our region for really promoting ductless heat pumps.
Great. And can you talk a little bit more of how long it takes to install a unit or several units in that case?
Yeah, so typically an installer can get in and out of an apartment unit in less than a day to install one single head unit in an apartment. So the installation goes pretty quickly. Okay.
You talked about the condensating water drain. Where does that go during cooling? Does that make a mess in wherever it's staged, or how does that happen?
Okay, so with in cooling mode, as warm air is blown over over the coil, it creates condensate. And it needs to be drained out. So like how your car, you see water dripping out of the bottom of your car when it's in the summer when you're using air conditioning. The same thing happens in the indoor unit with a ductless heat pump or really any cooling system. So generally the best way to deal with that is to run a condensate line along with the rest of the controls, wiring, and power to the outside. And usually that can be done with gravity. So it drips into a pan from the indoor unit and then flows outside through tubing. If gravity isn't an option due to the installation, a pump can be installed. It has to kind of go uphill and pump the water out of the indoor unit.
Great, thanks, Garrett. The last question you talked about was visiting that website to find out more information about heat pumps. Are there other places you can also, or the resources available to find out more information of how we should approach our next steps?
Yeah, the Energy Trust has great information on ductless heat pumps and programs for multifamily. Again, our website is a great resource. Ania has some great information on ductless heat pumps as well. So those are a couple resources as far as next steps. But yeah, recommend just kind of checking out PGE's site. We have a lot of good information on ductless heat pumps.
Great. And I'd like to give an opportunity for any of those that are still logged on. If you want to use your raise hand icon and you want to ask any further questions over the phone, we do have that dedicated time. Again, the raise your hand icon is located right underneath the participants window. Okay. Well, I did not get any other further questions. And again, as a reminder, we do have a couple of luncheons as well that you can join us on energy and water, irrigation trends, and investment strategies. We will also be offering a noon session of this today if you'd like to have someone else join us. And please do take a couple minutes to fill out the polling, and we will stay online in case a question comes up or you have other thoughts, but we did end early today. So thanks again, everyone, for participating. And again, we will be sending an email with the PDF of the presentation and the recording of the session, so you will have access to that. Make sure that we have your email on file. And again, if you are interested in the continuing education units, credits for the real estate, what we need is your license number, so you can chat that to me, or you can follow up with an email as well. So thanks again for joining us.